Methane. It heats our homes, illuminates our cities, and fuels our industry, globally. Methane has the power to influence politics and economics, globally. But it also has the power to destroy the planet as we know it, globally. The effects of methane on global warming and beyond. Okay, let's first take a look at methane itself to get us started. For everyone wondering if human activity really makes a difference, this is the methane concentration in the atmosphere over the last 800,000 years. I think you get the picture. Methane, or CH4, is a chemically active and really flammable gas that is responsible for around 20% of the global warming that has already happened. This makes methane the second most important greenhouse gas, directly after CO2. Speaking of CO2, carbon dioxide is usually the base on which we evaluate different greenhouse gases for their global warming potential, short GWP. Most common scale for GWP is the GWP 100 that takes a look at the global warming potential over 100 years. Methane has a GWP value of 28, so over 100 years, 1 ton of methane has roughly an equivalent impact as 28 tons of CO2, then called CO2 equivalent, or short CO2e. Okay, this was quite a lot of information to get started, but I needed to address this because here in this CO2 equivalent scale already lies some of the major problems we need to discuss today. Because even though the GWP 100 accurately describes what it wants to describe, and is also necessary for comparison, it doesn't tell you the whole story. Gases differ quite a lot actually, and methane is definitely not like CO2. Methane has an atmospheric lifetime of circa 12 years, whereas CO2 stays in the atmosphere for centuries to millennia. Thus, if we consider a 20-year timescale instead of 100, the potential goes up from being 28 times the impact of CO2 to being 81 times the impact of CO2. That's massive, and we all calculate with that. Industry, politics, almost every regulation and every report get their CO2 equivalent like this. And with this, you can emit a lot more methane without addressing the near-time effects correctly. All in all, though helpful, the GWP 100 misses the mark in reflecting the short-term impact of methane and other greenhouse gases. That in itself wouldn't be so bad if we'd had this 100-year time frame. But we don't have this 100-year time frame. We need to act now. This is especially important if you consider how rapidly we approach tipping points, for example, melting the polar ice and destroying the permafrost. This is not happening 100 years from now. But the title of this video is The Influence of Methane on Global Warming and Beyond. And at the beyond part, these scales just fall apart. As I mentioned earlier, gases differ in their properties. CO2 has its unique properties, which I will address in a future video. But generally, CO2 is the product of a reaction that releases energy, also known as an exothermic reaction. A common example of this is combustion or burning. Or in simpler terms, you set energy free when you burn something, so the energy in the product is lower. CO2 is usually the product, and methane is the fuel, so methane has more energy or is more potent, you could say. Even though methane is potent, it itself is not classified as a pollutant. But you remember the short lifetime in the atmosphere? Yeah, it oxidizes and it creates ozone. And ozone is quite harmful. In fact, ozone is so harmful that if we'd really implement our climate targets of 1.5 degrees, you know, the ones from the Paris agreements, we would prevent 255,000 premature deaths every year from 2030 onwards. And that only because we would lower the methane mitigation, thus methane generated ozone. 255,000. I mean, this is not what we are doing or where we're heading. But we could. In reality, global methane emissions will probably still rise. But don't you worry. Most of the people that are dying are from poorer regions of this world. But where can we mitigate or stop emissions? Well, 40% of the anthropogenic methane come from agriculture, mostly livestock and rice. 35% come from fossil fuels, gas, oil, and coal, and 20% come from waste. The fossil fuels have the greatest potential to easily and also cost efficiently cut emissions. Cite, up to 80% of oil and gas measures and up to 98% of coal measures could be implemented at negative or low cost. For waste, you could cut 60% for negative or low cost. Only for agriculture, it's a little bit more complicated. As I said, most of it is from livestock and rice, and even though there are several possibilities, most of them include a lower meat and or dairy consumption. So it's more consumer driven, but this also makes it the easiest way to do something yourself. Making these videos short and still informative can be a challenge. If you have further questions, please comment down below. And as always, this is a complicated matter broken down into a short video. I've linked all my sources and further information in the video description. But for now, I have nothing more to say than goodbye from me, Yuli Tsai.